So this is a brief overview of the circumcenter. The circumcenter is essentially going to be the intersection on my triangle of the three perpendicular bisectors. So over here, this is my first perpendicular bisector. Remember, a perpendicular bisector means that my segment intersects my line at a 90-degree angle. So over here we can see that this perpendicular bisector is going through AC at a 90-degree angle, and the second part of a perpendicular bisector, the bisector part of it, is that if I look from here to here, that is the same distance as from here to here. Now what I'm going to do is I'm going to take P4 and I'm going to label this D, and I'll create two more perpendicular bisectors between BC and BA, and I'm going to label them as well. So here I have my line going through BC and BA. Those are all perpendicular bisectors. Here I have a 90-degree angle, and I also have that this segment is the same length as this segment. I shall call P5 point E, and I also have on my left-hand side, let me label that first as F. Over here I have a 90-degree angle at point F between AB and my perpendicular bisector. And I also have that AF is going to be the same distance as BF. So now if we look at our overall picture, first of all, I'm going to label this circumcenter point. I'm going to call it point X. And let me drag this actually to make it a little bit clearer. So, oops. So hopefully this makes it a little bit easier to look at. So we can see that we have these three lines, and these three lines are all perpendicular bisectors on my triangle. So what is special about this circumcenter at point X? So the circumcenter, as we said, is the intersection of perpendicular bisectors. The special part of the circumcenter is that I can take extra segments from my circumcenter point X to all of my vertices A, B, and C, and they are all going to be the same distance. So AX is equal to BX is equal to CX. And we can actually show that over here. AX, these are the same, and these are going to be the same as well. Here. So now, what does it mean when I have segments that are the same length, coming from the same point? Well, we know that a circle is essentially, the radius is that every point on the circumference of a circle is equidistant to the center point. So what I can do now is I can draw a circle that connects the center with the vertices of the triangle, and I can inscribe this triangle into the circle, or I can circumscribe this circle. Now, let me first of all color this so that it's the same as, why isn't it working? Here. If we look now, I can drag my triangle into different shapes, and the circumcenter can even go on the outside of my triangle. However, no matter what 3 points I choose for my triangle, I'm always going to be able to find this circle on the outside. So in summary, the circumcenter is the intersection of the three perpendicular bisectors, and the special part of the circumcenter is that I can circumscribe a circle on the outside, meaning that the circumcenter is equidistant to the three vertices of the triangle.